पिला माने लास्ट क्लास रे आमे डिफरेंट टाइप्स ऑफ रिलेशन बिसरे पढिथिलु आज आउ किछि टाइप रे रिलेशन बिसरे आमे पढिबा सो लेट्स स्टार्ट फर्स्ट वन इज आवर एंटी सिमेट्रिक रिलेशन लास्ट क्लास रे आमे सिमेट्रिक रिलेशन बिसरे पढिथिलु सिमेट्रिक रिलेशन केते बेले हुए इफ AB belongs to R then there should be a BA which also belongs to R, or you can say ARB. If A is in relation with B, this implies B is in relation with A. A dite condition satisfy hele si amara symmetric relation hei thai. So anti-symmetric relation kete bale hue. Let A be any set. A relation R on set A is said to be an anti-symmetric relation if and only if AB belongs to R, or you can say ordered pair AB belongs to R and ordered pair BA belongs to R. This implies A equals to B for all A comma B belongs to A. तमने सबु A B capital A set ra elements heithibe. For example, let R be a relation on the set n of natural numbers defined by x in relation with y implies that x divides y for all xy belongs to n. This relation is an anti-symmetric relation on n since for any two numbers AB belongs to n. A by B and B by A gotte condition re justify heithai जेतबळे A equals to B heithai. That is A in relation with B and B in relation with A implies A equals to B. Symmetric re A equals to B haba necessary nuhe, but anti-symmetric re A equals to B hele hi AB au BA ordered pair belongs to R haba. Next is our partial order relation. केते बेले गोटे relation को आमे partial order relation कहि थाउ. A relation R on set A is said to be a partial order relation on A if it satisfies the following criteria. First one is R is reflexive. That means A ordered pair belongs to R for all A belongs to set A. Second is R is anti-symmetric. That is AB belongs to R implies BA belongs to R only possible when A equals to B for all AB belongs to A. Third condition is R is transitive. That is if AB belongs to R and BC belongs to R, it implies there should be an ordered pair AC which also belongs to R. For all ABC belongs to R. So, A तीनोटी condition satisfy कले आमे गोटे relation को partial order relation कहि थाउ. तमने relation जदि reflexive, transitive au anti-symmetric हेतिबा ताहले से relation हमारा partial order relation हबा. For example, R be a relation on the set n of natural numbers defined by x in relation with y implies x divides y for all xy belongs to n, then R is a partial order relation. Now let's move to the most important relation, that is equivalence relation. A relation R which is subset of A cross A is called an equivalence relation on A if it is reflexive, symmetric and transitive. तमने गोटे relation जदि reflexive relation हेतिबा, symmetric relation हेतिबा और transitive relation हेतिबा ताहले से relation को आमे equivalence relation बोली कहि परिबा. और जदि reflexive, transitive और anti-symmetric हेतिबा ताहले ताकु आमे partial order relation बोली कहि थाउ. So a equivalence relation पाई आमे similar sign use करथाउ. जेमती triangle similar to another triangle आमे करू. For equivalence relation also we use this symbol instead of r. So equality of any set, congruency and similarity on the set of triangles, parallelism of coincidence on the set of lines has the same as on a set of people are some of examples of equivalence relation. So now let's discuss an important equivalence relation on Z, that is congruence modulo relation on integers. So what do you mean by congruent modulo relation? So let AB belongs to Z. Kana ethi ame integers ma e relation justify karuchu. And let M be a fixed positive integer. We say that A is congruent to B modulo M and write this as A equals to B modulo M if M divides A minus B. For example, there are three numbers. One is 8, another is 4 and 2. Here A minus B, 8 is A, 4 is B and M is 2. So we can say A minus B is completely divisible by M here. So we can write 8 equivalent to 4 modulo 2. That means 2 divides 8 minus 4. So we can also write this as 8 equals to 4 plus 2 into k, where k is an integer. That means k belongs to Z. Here k equals to 2 in this case. So generally ame jetabale A equivalent to B modulo M, if M divides A minus B, taku ame arithmetically A equals to B plus MK babare bi express kari pariba when K belongs to Z. Some other examples are also given here. 10 equivalent to 1 modulo 3. That means 10 minus 1 divided by 3 equals to 3. Tamane A minus B divided by M gote integer heithiba, whether positive or negative heithau, but it should be an integer. Second one is minus 20 is equivalent to 1 modulo 7. That means minus 20 minus 1 divided by 7 equals to minus 3. Similarly, minus 9 is equivalent to 3 modulo 4. That means minus 9 minus 3 divided by 4 equals to minus 3. So, ये जो negative integer को हमें एमती भी लिखी परिबा, or we can write this as or 20 equivalent to minus 1 mod 7. We often write this as 20 equivalent to 6 mod 7. तो हमें तरह sign change कर दो. Sign change कर ले 20 equals to 1 7 minus 1 then modulo 7. So 20 equivalent to 6 modulo 7. We can also write in this way. So minus 9 equivalent to 3 modulo 4. हमें केमती लिखी परिबा? Minus 9 equivalent to 3 mod or modulo 4. We can write this as 9 equivalent to 4 minus 3 mod 4, or 9 equivalent to 1 mod 4. So, a case re amara 9 minus 1 equals 8 hai jiba. 8 is also divisible by 4. And previous case re 20 minus 6 14 hai jiba, and 14 is divisible by 7. So, from the above definition and above examples, we come to various conclusions. Jahaku ame ethi properties hisabre indicate karchu. Let ABCD belongs to Z. Tamane ABCD sabu gote gote integer and M be a fixed positive integer. A and B amara negative kimba positive hei pariba, but M should be always positive. Then first property is if A equivalent to B modulo M and X is any integer, then A plus X is equal to B plus X modulo M. And if A equivalent to B modulo M and C equivalent to D modulo M, then we can say A plus C equals to B plus D modulo M. AC equivalent to BD modulo M. For example, if 127 is equivalent to 119 modulo M, we can write 8 equivalent to 0 modulo M. Iti A ru au B ru both ru ame 119 minus kar delu. So A amara 8 re convert hegala and B is 0. Similarly, 10 equivalent to 2 modulo 4 and 8 equivalent to 12 modulo 4 jadi achi, then 10 plus 8, that is A plus C, 18 equivalent to B plus D, 2 plus 12, 14 modulo 4 भी हमें लिखी परिबा, and 10 into 8, 80 equivalent to 24 modulo 4. अब यदि हमें check करिबा, then we'll get 18 minus 14, that is 4. 18 minus 14 divided by 4 equals to 1. So it is divisible by 4. Then 80 minus 24 divided by 4 equals to 26 by 4 equals to 14. So this is also divisible by 4. So this is all about various types of relation.